In this video I will build a low-cost turning table. With a turning table we can make spectacular videos, scan 3D objects with photogrammetry, or we can use it to make perfect panoramic photos. The mechanical part is very primitive. I started with some wood that I have found around. For the motion I have used a stepper motor and a shaft from an inkjet printer. I bought these shaft couplers and ball bearings. I want to check if this stepper motor is able to move the rod and the plate that I will put here. To check it, I'll use Arduino, stepper motor driver and a prototype board. I will make a simple sketch to move the motor. I create a variable for each pin of the driver and another one to drive the motor. I pull up the enable to turn on the driver, and I pull up all the microstepping pins to achieve 1/16 microstepping. In this way I lose precision, but the motor becomes less noisy and vibrating. In the loop I start generating impulses, inverting the value of the inputs variable. This delay changes the speed of the motor. The voltage regulator was not needed, since Arduino can tolerate 12 volts on the V input pin. But in this way, if I want to change power supply, I can increase voltage up to 36 volts. Now I have to find out the number of microstepping needed for a complete turn. I'll put a for cycle in the program and I test some values to see which one is equal more or less to a complete turn. Even if you don't drive the motor, the driver keeps it braked, and this causes overheating. When you keep the motor steady for a long time, turn off the driver pulling up the enable pin. I want to be able to set the RPM speed, so I create a variable that generates the right delay between each microstep. I implement this variable in the sketch. And now I can modify the RPM speed. I had an infrared sensor. The infrared sensor detects when something stops the beam between emitter and receiver. I use the digital read on the air sensor pin, and if the state of the pin is low, I make the buzzer sound. This will be useful in video editing. The audio track will help me to make a single churn in loop. To make a front panel, I need to remove the power connector. I had a button to start and stop the motion. Now we have a churning table with an USB port to program the speed. This is the first test. The panoramic shot is almost perfect. In the next days, I'll try to use it to make a rotating time-lapse and a 3D scan.